In this lesson, I'll show you 3 separate examples on how to integrate trigonometric functions. Let's start with question 1. In question 1, they want us to integrate between 0 and 1 for the function x times sine x to the power of 2 dx. What we have to do is match this function so that it looks like one of these patterns. The closest we can get this function to one of these patterns is this one, where the integral of sine u du is equal to negative cosine u plus c. Here's what we'll do. We'll set this part of the expression x to the power of 2 equal to u. So technically we're doing a u substitution. Now we'll derive both the left and the right side with respect to x. Taking the derivative of this side, I end up with 2x dx, and over here I end up with du. Solving for dx is equal to du over 2x. Look what happens when we substitute the content of dx into here. We end up with the integral between 0 and 1 x sine u, remember we replaced this with u, du over 2x. This x and this x cancel out, and I can pull out the 1 over 2 outside of the integral. So I have sine u du. Now we have an exact match of this rule, where the integral of sine u du is negative cosine u plus c. We won't have a plus c in this example because this is a definite integral. But I'll replace this with negative cosine and what we set u as, which is x to the power of 2. I'll need to evaluate this at 0 and at 1. At this point, you can even pull out this negative, placing it outside, just to prevent any sort of confusion. Evaluating cosine x to the power of 2 minus cosine 0 to the power of 2. That's the ratio that you get in degrees. If you were to put this in radians, you would end up with the following. It's up to you which one you want to choose. They don't specify. I'll continue using this times negative 0.5 gives us an answer approximately 0.23. That's the area underneath the curve between 0 and 1 of this function. Let's move on to question 2. They want us to integrate the expression cotangent 5x over cosine 5x. Once again, we need to match this with one of the known integrals, and at this point we don't know which one to match it with. So let's see if we can manipulate this function. Let's set this as f at x. Let's see if we can manipulate it before we take its integral. Cotangent 5x cosine 5x. What we can do is replace cotangent with its identity. Remember, cotangent x is equal to 1 over tangent x, and tangent x is equal to sine x over cosine x. And if I manipulate this quotient now, I should end up with cosine x over sine x. So let's go ahead and replace this with cotangent 5x, and of course instead of x we'll write down 5x for both of them. Cosine 5x over sine 5x over this cosine 5x. We have this quotient divided by cosine 5x. What that becomes is cosine 5x over sine 5x cosine 5x. This will cancel out with this, leaving us with 1 over sine 5x, and remember 1 over sine is the identity for cosecant. So we can say cosecant 5x represents 1 over sine 5x. I'll take the integral of cosecant 5x instead of this. The integral of cosecant 5x dx. This matches with the second rule. What we have to do now is set 5x equal to u, take the derivative, dx times 5 is equal to du, and dx is therefore equal to du over 5. So we have the integral of cosecant u du over 5. Pull out that 1 over 5. No need to integrate that. And all we do now is use the rule where all of this becomes 1 over 5 times ln the absolute of cosecant u, which is 5x, minus cotangent 5x, close the absolute, plus c. I know it's crammed, but that is your final answer for question 2. Lastly, for question 3, and I'll do my work up here, we need to take the integral of tangent 4 minus 5 theta. The integral of tangent 4 minus 5 theta with respect to theta. This is a very simple question. We set this equal to u, 4 minus 5 theta. Take the integral with respect to theta. We get du over dx is equal to negative 5. Solve for dx, we should end up with du over negative 5. Then from here, and you can do this one on your own, you'll use this pattern, substitute u with 4 minus 5 theta, and you should end up with the following integral. And so there you have it. 3 examples on how to integrate trigonometric functions.